Well, hello there. Welcome to a story that's wetter, wilder, and more surprising than you might ever expect. Let's dive into the wild, unpredictable weather that swept across the UK in 2025, a year that will go down in meteorological history. Picture this: the United Kingdom, famous for its gentle drizzle and gray skies, suddenly outraining even Seattle, the city that practically invented rainy days. This past November, the UK was hit by a record-breaking deluge. Hillsides turned into rivers of mud, and rural roads became impassable as relentless rain transformed the landscape. The downpour was unyielding, a constant drumming rain that shattered previous records and left communities scrambling to stay dry. While Seattleites enjoyed an unusual stretch of sunshine, Brits rushed to buy waterproof gear, umbrellas, and wellies, bracing themselves for the next wave of rain. But how did the UK manage to outrain Seattle? The answer lies in a fascinating tale of powerful oceans, shifting winds, and the complex dance of global weather patterns. We're about to embark on a scientific adventure, digging deep into the data and clues that explain this extraordinary event. Together, we'll explore the invisible forces that move water around our planet and discover how even small shifts in climate can lead to massive, unexpected soaks. By comparing these famously wet regions, we'll uncover the surprising reasons why the UK won the rain-off of 2025, leaving Seattle in the dust, or rather, the sun. It's all about the science of our interconnected world, where weather in one place can ripple across continents and oceans. So, buckle up and grab your raincoat for this wild weather adventure. We're about to unravel the secrets behind the UK's epic soaking. Let's solve the mystery of how a nation known for drizzle became the world's rain champion, if only for a season. It's a fascinating story of global weather dynamics, human resilience, and the unpredictable power of nature. Consider this. Let's talk about Seattle, a city that's become almost synonymous with rain. When you think of Seattle, you probably picture gray skies, people in rain jackets, and, of course, the iconic Space Needle rising above it all. But is Seattle really as rainy as everyone says? Seattle's reputation for being damp is well earned. The city experiences over 150 rainy days each year, and locals have practically mastered the art of carrying an umbrella or just braving the drizzle without one. The wet sidewalks and glistening streets are a familiar sight, and the gentle patter of rain is almost like background music to daily life here. But here's a twist. Seattle's rain isn't usually the dramatic, thunderous downpour you might expect. Instead, it's more of a marathon than a sprint. The rain here is gentle, persistent, and often feels more like a mist that lingers for hours, sometimes days, rather than a sudden storm. This light, steady drizzle is what keeps Seattle so lush and green. The parks and forests thrive, and the city's gardens are vibrant year-round. It's a rain that nourishes rather than overwhelms, creating a unique atmosphere that locals have come to embrace. Now, let's hop across the Atlantic to the UK, a place equally famous for its rainy reputation. But the rain here is a different story altogether. In the UK, rain can be varied and unpredictable, sometimes arriving as a sudden shower, other times as a relentless downpour. The UK's weather is famously changeable. It's not uncommon to experience sunshine, rain, wind, and even a bit of hail, all in a single afternoon. Locals joke about needing to carry sunglasses and an umbrella at all times, just to be prepared for whatever the sky decides to throw at them. This variability is a key clue in our weather mystery. The unpredictability of British rain means that no 2 days are ever quite the same, and it keeps everyone guessing. While Seattle's rain is predictable and almost comforting, the UK's is a dramatic performance, sometimes gentle, sometimes wild, and always a little bit surprising. In a normal year, it would be a close contest between these two rainy giants. Both have their own style, their own rhythm, and their own stories to tell about life under gray skies. But 2025 was no ordinary year. Something extraordinary happened, tipping the scales in the UK's favor and making it the center of attention for weather watchers everywhere. In 2025, the UK's usual rain turned into a super soaker event. Torrential downpours flooded streets, rivers overflowed, and emergency responders were called out again and again. It was a year that broke records and left a lasting mark on communities across the country. Meanwhile, over in Seattle, people were left scratching their heads. The familiar drizzle seemed to vanish, leaving the city drier than usual. Locals peered out of coffee shop windows, wondering where their trademark rain had gone. The answer to this weather puzzle lies in a global climate pattern, a powerful force that connects these two regions, shifting rain clouds and altering weather in ways that can surprise even the experts. It's a tale of two contenders for the title of rainiest place, each with its own unique relationship to the rain. So, what really happened in this unusual year? Let's uncover the story behind the rain and find out how a global shift turned the weather upside down for both Seattle and the UK. To understand the UK's epic rain, we look to the Atlantic Ocean. The Atlantic acts as a giant engine for the UK's weather. Warm water evaporates, creating a moist atmosphere. This moisture hitches a ride on the jet stream, a fast-moving air river. The jet stream carries moisture-laden air to the UK, where it cools and condenses into rain. This process is the UK's primary source of rainfall. In 2025, this system went into overdrive. The Atlantic sent a barrage of moisture, with the jet stream acting like a fire hose. Storm after storm slammed into the UK, each carrying a massive payload. This supercharged Atlantic Express is a major clue to the Great Soaking. The UK's rain machine was in full force, creating a record-breaking deluge. Let's explore how this system turned the UK into a flood zone. Now, let's travel west to Seattle and its water source, the Pacific Ocean. The Pacific is a colossal weather engine influencing the climate of the Pacific Northwest. Moisture from the Pacific is carried by winds towards Washington state. When this air hits the land, it rises over mountains, cooling and releasing rain. This orographic lift is why Seattle gets its signature drizzle. The Pacific's reliable system creates frequent sustained rainfall, but in 2025, this system slowed down. The answer lies in a global climate pattern affecting both oceans. Let's uncover what went wrong with Seattle's rain machine. Enter La Niña, the global weather shaker-upper. In 2025, La Niña altered the weather patterns of two oceans. La Niña, part of the El Niño Southern Oscillation, affects global weather. It strengthens trade winds, pushing warm water west and allowing cold water to surface. This cool water changes air temperature and pressure, altering jet streams. La Niña reroutes weather highways, making some places wetter and others drier. It influences hurricane seasons, causes droughts, and brings heavy rains. In 2025, La Niña was the main culprit behind the UK Seattle rain showdown. It was a global domino effect, changing weather across the planet. Let's see how La Niña's influence played out in this weather drama. How did La Niña cause a historic soaking in the UK? It all comes down to the jet stream. La Niña nudged the North Atlantic jet stream, making it stronger and wavier. The jet stream aimed directly at northern Europe, creating a persistent storm track. Storms, laden with moisture, were funneled along this superhighway to the UK. It was a perfect storm of meteorological circumstances. The jet stream became a professional bowler, hitting the UK with full force. This wasn't just bad weather, it was a relentless assault of storms. The atmospheric river became a raging torrent. Storm Barnaby, a classic example, unleashed days of torrential rain. La Niña's influence on the jet stream created this conveyor belt of chaos. The UK's climate turned into a full-blown flood factory. While the UK was drenched, Seattle experienced a dry spell. La Niña steered storms away from the Pacific Northwest. A high-pressure ridge formed over the eastern Pacific, blocking storms. This ridge acted as a shield, diverting moisture-laden air northward. Seattle was stuck in a dry zone, with sunny days and clear skies. The Cascade Mountains waited for moisture that never arrived. This is a classic La Niña pattern for the Pacific Northwest. A strong La Niña often leads to drier conditions in Washington. The same phenomenon that drenched the UK shielded Seattle from rain. It was a tale of two outcomes from one cause. Let's explore how La Niña's influence created this weather contrast. It's a perfect example of our interconnected climate system. Let's compare two storms, Storm Barnaby in the UK and a non-event in Seattle. Storm Barnaby was a beast, hitting the UK with wind and fury. It unleashed relentless rain, overwhelming rivers and drainage systems. Emergency services worked tirelessly amid the constant downpour. Meanwhile, Seattle enjoyed partly cloudy skies and sunny days. The high-pressure ridge deflected storms north, leaving Seattle dry. People in Seattle enjoyed outdoor activities, wondering about the weather. The contrast was stark: floods in the UK, dry spells in Seattle. It was a real-world demonstration of La Niña's power. La Niña rewrote the weather map, creating feast in one location and famine in another. This tale of two tempests highlights the global impact of climate patterns. Let's delve into how these storms illustrate La Niña's influence. It's a fascinating story of weather dynamics. In the Great Rain-Off of 2025, a surprising twist occurred. The United Kingdom, long known for its drizzly days, actually outrained the famously soggy city of Seattle. But what caused this unexpected reversal in the battle for the rain crown? The answer is a fascinating blend of geography, oceanography, and the powerful climate phenomenon known as La Niña. These forces combined to create a perfect storm, quite literally, for the UK. Both Britain and Seattle are no strangers to wet weather, thanks to their locations near vast oceans. The Atlantic shapes the UK's climate, while the Pacific influences Seattle's. Typically, the UK receives its rain from moisture-laden winds blowing in from the Atlantic, while Seattle's rainfall is delivered by Pacific storms. But in 2025, La Niña changed the rules. This climate pattern shifted the jet streams, those fast-moving rivers of air high above us, causing them to behave in unusual ways. For the UK, this meant the jet stream funneled storm after storm directly over the islands, turning the region into a storm superhighway and resulting in record-breaking rainfall and widespread flooding. Meanwhile, Seattle found itself under a persistent high-pressure system, a kind of invisible shield that pushed storms away, leaving the city drier than usual. The global rain machine was still running at full speed, but its output was redirected. Instead of drenching Seattle, the storms traveled elsewhere, leaving the Pacific Northwest unusually parched. This remarkable event highlights just how interconnected our planet's weather systems truly are. A shift in one part of the world can have dramatic effects thousands of miles away. So, a change in the Pacific Ocean's temperature patterns led to devastating floods in the UK and unexpected dry spells in Seattle. A vivid reminder of our global climate's complexity. As our climate continues to change, understanding these patterns becomes more important than ever. Meteorologists and scientists are working hard to predict and prepare for these shifts. The 2025 Rain Showdown was a textbook example of La Niña's far-reaching influence and a case study for future climate research. So, who will claim the next rain crown? Only time and science will tell. One thing's for sure, science is cool, and it helps us make sense of our ever-changing world.